now.
Sounds good. I already kind of like looked over it a little bit.
Yeah, me too. I think it's just hard to figure out like the null hypothesis and the alternative hypothesis and kind of the difference between them.
Okay.
There are 21 questions.
Mm-hmm.
That'll at least help our averages, though.
Okay. Whenever you're ready, let me know.
Yeah, I'm ready.
Oh, okay. So 1 and 2, easy enough. 3.
3 I thought was the null.
Yeah, because I think it says it in the reading. Yep.
Yeah.
Messed with the volume.
Yeah.
Yeah, so it's the null.
Yeah.
With p-value, I think that all has to do with alternative hypothesis.
I'm having to refer to the reading for everything, so.
Because if we look at the p-value section of the reading, it just talks about the alternative.
Yeah.
If you look at p-value. Okay.
Oh, okay. Yeah, so I would say it's alternative.
And if not, it's the other one. No.
And 5, which of the following represents the alternative hypothesis for a two-tailed test?
So if you guys scroll down in the book, it gives us a chart of two-tailed, left-tailed, and right-tailed.
So it would be
I think it's the equal with the lines through it.
the third option?
Yeah.
I would say so, because it gives the examples. We're on relationship to alternative hypothesis, that section in the book.
Okay. Oh, okay, yeah.
Okay.
Yeah,
So-
it literally gives examples.
Yeah.
And
So
that
that
makes
means
6 easy too.
Left-tailed, yeah, it would just be less than 10, or the first option.
Yeah.
And then 7 is just the other way.
The second option.
Yeah, everything greater than 10.
Mhm.
Which relationship would result in the failing to reject the null hypothesis? This is what confused me. It just is so like wordy.
Yeah.
Yeah. Who doesn't want to check them off?
Would be failing to reject the null hypothesis.
So that would mean the null hypothesis, or that the hypothesis is true.
Yeah, that would mean it's true. So would it be the second option?
The p-value.
Isn't A like, I forgot the word for it. I guess we assume like what we think it is.
So it would be, because A stands for alpha, right?
Yeah, I would say the second one.
Yeah, I would agree with that.
That it's less than?
Yeah.
Okay, yeah.
Which relationship would result? Wait, what? Is that the same answer? Rejecting the null hypothesis. Wouldn't that be shows the p-value? So wouldn't that now be the first option? So I'm thinking now it would be the first option because the p-value is the alternative.
So big, and then I get like random people like that that are like
Yeah.
local and I'm your
That's just my guess.
Jacob, who is Camilla's brother.
I mean, it's one way or the other.
Yeah. The next one, which of the following would be appropriate alternative hypothesis? Can you get a mix?
So reject would be less than.
Okay, so we mixed them up.
Yeah, so we mixed them up.
Wait, did we? No, we didn't. Oh, yeah, we did.
And then do not reject hypothesis.
So we mixed them. So flip flop. 8.
Okay.
I just found it in the book.
Where did you find it in the book?
So I'm just looking. I lost it. So I'm looking at like level of significance talks about small enough to reject the null hypothesis. It's level of significance.
Mm-hmm. Oh, okay, yeah. I see it.
Yeah, I just kind of guessed from there.
Okay, awesome.
Okay, 10. This is the stuff that kind of confuses me. The appropriate alternative to hypothesis. When originally believed that the average coming out was 100.
The same exact Turn equal to is not equal. So I think it would be the amount is less because they're wondering if it's the average is 1,500, and then they're concerned that the true mean is actually higher than this, so that would be greater.
True.
So because alternative would be like what they thought was proved wrong.
Yeah, no, I agree. Which of the following would be the appropriate null hypothesis? So wouldn't it say it was 1,500? So would we say is greater than or equal to? Saying the average.
Yeah.
So would it be?
I think
equal.
it would be equal.
Okay.
Are you serious? What?
So an insurance company assumes that the distribution of the sample mean is normal. Is this a good assumption?
Yes, because the samples were greater than 4 or 30, right? Because since the sample size is large.
Mhm. Yeah.
Which theorem or law justifies your answer to the previous question?
That was the law of large numbers, right? Or no, central limit theorem. I have.
Let's see.
Let me here.
The mean is normal.
Central limit theorem. I think I like central limit theorem because it talks about how you need large numbers.
I think central limit theorem does involve the square rooting of the sample size and all that.
Now we're just going to pick out the test statistic. So would it be 40? They randomly selected 40 people, so would it be N for number 14?
Test statistic.
Because they randomly, because N equals 40, they randomly selected 40 people. So aren't they the test?
Yeah, but what's they'd be like the sample size, the test statistic. Would be Z is the test statistic.
Oh.
So did you get that one, Jensen? 14Z?
Yeah, well, yeah, because I'm reading it right now. So yeah, it says Z.
Sweet.
Now we're getting to the hard stuff.
Yeah. What is a z-score associated with this test?
Okay.
Just plug it all into the formula.
Yeah, I think we just do that formula.
So that one.
We don't have a standard
Yeah, we do.
deviation, though.
40.
Oh.
Mm-hmm. And we even have the mean. So it would be and then we have x barred is 144. Where do we plug in that A? Or do we?
I'm trying to see.
Okay.
Divided by... Okay, so I have the z-score. It wants us to round to 3 decimal places.
We didn't even get 3, huh?
No, let me double check it. I'll be on my other calculator.
Because don't you just do...
So we do 144
Yeah.
minus 150. That divided by 40.
Wait, 144 is... Hold on. Yeah, you're right. What are you plugging into the formula?
So I did the 144 minus the 150, and then because it's asking for, or it gives us like a sample size, so we'd square root that, right, and then times it.
What do we? Oh, the 36 sales representatives. Yeah.
Oh, I didn't even...
Sorry, I totally.
Yeah.
So -6 divided by 40
Square root of 36.
divided by square root of 36.
Times 6.
Well, we divide it by 6, right? Or -6.
Yeah.
So I got -0.9.
We need 3 decimals.
Yeah. Okay, so maybe we don't use that then.
I just don't know what else we'd use.
Random sample.
Reminders. Where do we tie in this significance?
The level of significance.
Mm-hmm.
I'm reading about it right now. So I think that the level of significance only deals with the p-value being small or large enough in order to reject the null hypothesis, which I don't think would apply to this question right now because it's just asking about a z-score.
Okay. So try to do this one more time.
I did again. I got -0.9.
We can try it, you know what I mean? We might be right. What is the p-value associated with the z-score? So now I think we go to the applet, right? Then we plug in the z-score into the applet.
Large P, small p.
I'm so confused.
Yeah, because I don't know what to shade.
Well, what did they give us
Like, you can follow the check.
for the
If you might go back to the
so equal to and then a less than the left side.
So you just do the left side.
Ooh. So then would that be 0.184?
I think so.
Okay, I'm fine with that.
I don't know what we call it.
What inference would you make about the null hypothesis for this problem?
If the P is low, reject the null.
The P is the P is lower than no, it's not.
I would say it's a low P.
Yeah.
I thought in like the video he compared it to this. Like, was it lower than this 0.5?
Oh, yeah.
So I would say
Oh,
fail to reject.
That's why.
Yeah.
So what's your conclusion for this problem? Okay, so we failed. So it's true.
So is it less than
So
150?
we have sufficient evidence that the true population mean is less than 150.
Or is it 150?
Ooh, so it's either the second or the last option.
Yeah.
I would think it's less than.
Okay, you're from I think so.
Yeah.
Okay, there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
Isn't that a 2? Oh, it's a type 1.
When you reject it, yeah, it's 2.
Are you
Sure, I remember in the reading.
We just look at the chart. If you go to type 1 and type 2 errors,
Oh, here we go. So what's the problem saying that our
the hypothesis, but the hypothesis is true would be a type 1.
I was rejecting the null? Yeah.
Even if it's not my fault.
okay. Okay, so he just made the significance less. Would it be harder to find?
So the book says if we choose an alpha or the significance to be so small that we rarely commit a type 1 error, it would happen to the probability of committing a type 2 error.
It's like a question.
Right, and then reading on.
Probability is very small. So the probability of a type 2 error, well, that's saying the increase.
Type 2 error would be large, so it would increase.
For the second one?
Yeah.
The last one. Compute the probability of committing a type 1 error. To be honest, I don't know how to do that.
Let me compute it. haven't had it.
Would it be in that section?
So I think oh yeah. Because it says we use the applet to determine the probability.
So the most common value for alpha is 0.05. This is equal to 1/20th. Isn't that the, yeah. So when the null hypothesis is true, there is a 1 in 20 chance that it will be rejected at the 0.05 level of significance. Other common choices. Okay, that is not applicable. So, so when the null hypothesis is true, it's a 1 in 20th. So would it be as easy as dividing 1 by 20 and getting the decimal answer?
We can try it.
But that did nothing.
Yeah. What do you think?
Yeah, because the type 1 would be rejecting the null. Oh. Yeah, we could try that. I mean, I'm just looking to see if there was an example.
The thought process I have is not going to work. 1/20th or 1 divided by 20 is 0.05. So.
Well, what if we do 1/20? Would we times or divide it by 0.05?
So you're saying do a 1/20th divided by 0.05?
Well, that's
well, that would just equal 1.
Yeah. So I'm trying to see if this was anywhere like in the answer, like in the prep assignments.
If we times them together, it gives us enough decimals.
Yeah. Because we just do like that percentage, like that decimal times this, and then that would give us. I don't know what else.
Because if we round to 2 decimal places, it's just going to be 0.00.
Yeah. I'm trying to see if there's like any example of this.
Okay, so it says that the level of significance, or the alpha, is the probability of committing a type 1 error.
Oh, so is it just 0.05?
I think so. Well, I mean, that seems really simple, but.
But we've had so many where we've talked ourselves out of so many answers.
That's true. That's very true.
Do you want me to be the first one then to
Yeah,
submit?
then I'll catch you up.
Yeah. It was so nerve-wracking to submit our quiz or
Our test.
Oh, I know.
Guys,
that test review saved my life.
Yeah. We only missed.
Yeah, she did awesome. I wish she could do that for like every lesson.
That's what we were saying.
She should. That would be so helpful.
We were both like, oh, I wish after we watched it, we were like, this would be so nice weekly.
Yeah.
Okay.
Yeah, definitely.
Okay, well, Josh said we only
number
missed
4
is wrong.
Is obviously null hypothesis. Totally my bad.
Okay.
And then
what's the next strong
number
one?
10 is our next strong one. So it would.
So I'm saying it would be not equal to. Because look, did we get the next one right? So it would be not equal to, because if the next one is equal to.
Is equal. Okay, yeah, that makes sense.
What's the next one we
And
got
then the
wrong?
next one was number 18.
We didn't miss any fill in the blanks?
No.
Holy cow. It's a miracle.
So that would be that we have significant evidence that the true population is 150.
I can submit it and see.
Okay.
Mhm.
Okay, ready?
Yeah.
So it's null. Oh.
Grab it.
Wow, I'm genuinely
Hey,
surprised.
guys,
Like,
we're
we
getting
did it.
better.
We're
Yeah,
geniuses.
sweet.
Okay, number
So
3.
it's null.
Four is
Do you
null.
want me to
Four's not-
submit mine as you catch him up?
Yeah. The third option, first option, second option, first option, second option, second option, first option, first option, second option, second option,
Okay, so we missed number 10 again.
negative 0.9. Okay, let me catch him up and then we'll revisit it.
Okay.
0.184.
Is that the only one we missed?
10 and 18.
Okay. Fail to reject. Okay, so 18. Well, now I'm confused.
We should have you submit that we don't have insufficient
So is it the
evidence.
first one? We use sufficient evidence that the true population mean is 150? No, because that says insufficient. So would it be we have insufficient evidence that the true population is less than 150? That's pretty much saying what the bottom
We
one's
can
saying,
try
just
that,
different.
Oh, yeah, because we don't have evidence against it.
Yeah, so these are just going to be like the ones where you have to read so carefully.
I know.
Okay. I'll submit it and see if it's right.
Well,
Oh, 10 was wrong too, huh?
Oh, yeah, 10.
Yeah.
Let me get to it. Okay, 10. The average case, so it's
So it'd be greater.
would it be greater or is equal to?
Because it's HA, right? So if we look here,
Want me to try
I
it?
think it is greater.
Okay, let me see. You want to catch Jensen up while I?
Jensen, do you need to get caught up?
Yeah, I was just going to open a new thing, but yeah.
Oh, we got him.
Just give me a sec to refresh it.
So that new one's right.
Okay, so what was 10?
We got it all. So 10 was 2, 3, 4, 5, 6, 7, 8, 9. Because 10 is the claim amount is
Okay.
greater than 1,500. Why would that be? Because they're saying the average is 1,500.
Okay, so null hypothesis A.
Oh, okay, because it's alternative hypothesis.
Oh, yeah. Okay.
Sweet.
And then 18, what'd you put aside? Okay.
Okay, so 3 was the null, right?
Yes.
Mm-hmm.
Okay.
4 was also the null.
3 was the null. And 5?
Is the third option with the equal sign through the line.
Okay.
6 is the first option.
Okay. And 7?
The second option.
And then 8,
The first option.
the greater than.
Yes.
Okay. And then the less than, right?
Yep.
And then 10, what did we say it was?
The amount is greater than, so the third option.
Okay.
11 is equal to 1,500.
Okay.
12 is
12 is
assumption
large.
sample size is large, yeah. 13, central limit theorem.
14 was Z.
Yep.
Okay, and then 15.
Negative 0.9.
Okay.
16 is 0.184.
4.
17 is failed to reject.
Okay.
18 is insufficient evidence that the true population mean is less than 150.
Okay.
19 is type 1. 20 is probability of type 2 error will increase.
Okay.
And then
And
is 0.05.
okay.
Sweet. We are
Awesome.
okay. We will see you on Tuesday.
Okay.
Okay,
Yeah.
thanks, Ton.